Good morning to all. In the previous lecture of process equipment design, we are discussing power requirement for agitations. Okay, so let's recall and the overview of power required for agitations. So power number exactly it is defined by the ratio of drag force acting on a unit area of the impeller on a inertial stress. Okay, so that is np power number, which is np pgc by rho n cube d raised to 5, and Reynolds number, and then Frod's number. So how they are related with each others, and we discussing about the uh, formula. Okay, now then after we discussing a scallop for agitation vessel. Okay, now next one is that agitator drive system. Agitator drive system theorem. Let's see how works agitator, which parts are in the agitator, uh, and using these how can we reactions can be take place in the reactions in the vessels. So let's see agitator drive systems. Okay, agitator drive systems consists of electric motor, belt drive, or a gearbox. Agitator drive system consists of electric motor, belt drive, or a gearbox, and coupling identical, then gearbox is not required. Okay, that means the agitator drive it may be consistent of first electric motor, then belt, electric belt or drive, or then gearbox. Okay, and require coupling. Electric motor supply the power. Okay, if the rpm of electric motor shaft and agitator shaft are identical, then gearbox is not required. Identical, that means they are joined with uh, initially they are connected with each other, so there is no required for the gearbox. Gearbox transmit the power of electric motor shaft to agitator shaft directly, or sometimes due to the other shaft. The main function of the electric motor is to the driven the agitator shaft. Okay, and it is directly connected with the agitator shaft, and sometimes they are using some another shaft which is attached with agitator shaft. Okay, so sometimes it connected with other shaft. Okay, now कपलिंग्स आर यूज टू कनेक्ट द साफ्ट. कपलिंग्स को यूज़ किया जाता है साफ्ट, दो साफ्ट को कनेक्ट करने के लिए. सो लेट अस सी द कंस्ट्रक्शन ऑफ द एजिटेटेड वेसल. ओके, सो इन द top of the order, so there is an electric motor. They are connected with a gearbox which is attached to the um, shaft of the vessels, and pedals, agitators. Okay, so in the agitators there are pedals are anchor agitators are used. Okay, then support bracket, which is a supporting bracket which is connected to the electric motor, and then connected coupling which is connected to shaft. There are stuffing walks. Okay, then left hand side this one is a shaft, and second thing is coil. So coil is generally for the heating medium or a cooling medium supplied to the vessel inside the liquid. Then next one is agitator anchor, types of agitator. Okay, in which this one is a anchored, and steady bearing which can through we can remove we can the बियरिंग दैट मीन्स जो साफ्ट है वो नीचे बियरिंग के साथ कनेक्टेड होता है जो फ्रीली मूव हो सके. And then outer side it will be a jacket, then bracket support for the vessel के लिए, और these are the vessel. Normally gearbox itself has a two shaft. Okay, one is attached to the electric motor shaft by coupling, and other one is attached to the agitator shaft by the coupling. Okay, electric motor, gearbox and coupling are having a different types. We know that electric motor, then gearbox, couplings, which having a different type. We are not going to study these things in detail. If you want to study about the types of coupling and used of various types of gear drive, you can refer any book of machine design. Okay, this power transmission system create the power loss and is normally taken as 20% of agitator power consumptions. Okay, now this one is next one is stuffing box, in which जो स्टफिंग बॉक्स होता है जहाँ जहाँ पे हमने देखा, तो वहाँ पे ये कपलिंग कैसे कपलिंग को और साफ्ट को कैसे सील करता है और हाउ कैन इट्स यूज्ड. सो दिस वन इज़ अ साफ्ट सील्स. साफ्ट को कैसे सील किया जाता है. During the process, liquid vapor or gas. During the process, liquid vapors or a gas should not leak through the agitator nozzle. આ શાના માટે કરવામાં આવે છે? Because of this reason is that if there is a gas or other liquid who are in the vessels for the reaction, they are not leakage from the nozzle of the vessels. Okay, so इसीलिए यहाँ पे स्टफिंग बॉक्स के अंदर साफ को सील किया जाता है. So agitator shaft is properly sealed to prevent any leakage of fluid from the inside of the vessel to outside or from the outside to inside. Okay, so this one is most important part of the agitated vessel, that is shaft seals, which is used to prevent the leakages of any liquid and gaseous component or inside to outside as well as outside to inside. Okay, in the case where the reaction carried out under vacuum, the most common method of sealing shaft is with stuffing box and gland. Okay, there is an vacuum processes in the vacuum chamber and the agitations is required, then the most common used method is that sealing the shaft is with stuffing box and gland. So they are generally seen in the figure. Okay, so जो वो क्या करेगा, they are generally the connected shaft to the and the detailed figure of the mechanical seal is given here. Okay, shaft seal, and this one is a mechanical seal, one of the type. Okay, 5.4 is a stuffing box and which is used, or this one is a mechanical seal, it having a various part. So let's see this one is a shaft, vertical cylindrical shaped line, it is indicating the shaft, and this one is a shaft sleeve, they are connected to the shaft, and then this one is a o-ring, then it will be a fixed ring, then it will be a rotating ring, and this is the gland. Okay, so let's see this stuffing box is having cylindrical shape. It is in the form of cylindrical shaft which is placed around the shaft के आजू बाजू पे उसको प्रोवाइड किया जाता है. Its inside diameter is greater than the outside diameter of shaft. इसका inside diameter जो शाफ्ट जो एजिटेटर का जो शाफ्ट होता है उसका डायमीटर से क्या होता है, बड़ा होता है. ओके, in between the packing material is which providing the sealing, અને આના વચ્ચે શું પ્રોવાઈડ કરવામાં આવે છે, sealing material. Gland is also cylindrical form and it is also placed in between stuffing box and shaft. Gland, okay, as per we shown in the figure, which is also used in the stuffing box and shaft. but gland occupies only some top portions of stuffing box. Inside of the gland is nearly equal to outside of the shaft. Gland is made up from the hard metal like a steel, but it is attached with sleeve at a inside surface. And then sleeve is made up from the soft material. Sleeve of gland packing material combinedly provide the proper sealing of the shaft. If all the flowing conditions are satisfied, then stuffing box with gland can be used as a sealing system. First, P is less than or equal to 10 kg per centimeter square. Second thing is T is less than or equal to 120 degrees centigrade. And third one is N is less than or equal to 300 rpm. If any condition is not satisfied, then mechanical seal should be used. Mechanical seal consists of a two ring. One ring is stationary and other is rotating with a shaft. Okay, one ring is a stationary and other is a rotating with a shaft. Intimate contact of two rings provide a sealing. Rotating ring is a metallic and stationary ring is made up from the nomen non-metallic material like carbon and graphite. Okay, that means rotating is first mechanical sealing system, in which first condition should be followed, that is P is less than or equal to 10 kg per centimeter square. Okay, and it having a temperature range is that T is less than or equal to 120 degrees centigrade. And then third one is numbers of speed should be less than 300 rpm. If any condition is not satisfied, then mechanical seal not should be used. Okay, mechanical cell consists of two rings. Mechanical seal consists of two rings. One ring is a stationary and other is rotating with the shaft. Intimate contact of two rings provides sealing. Rotating ring is a metallic and stationary ring is a made up from the non-metallic material like a carbon and graphite, and this sealing system creates the power loss. Barabar? Due to the this mechanical seal, power loss is occupies that because of this system we are using. So because of the frictions, so normally power loss created in sealing system is taken 10 percentage of the agitator power consumptions. जो भी agitator power consumption करेगा उसका 10 percentage calculate करते हैं. The power output of electric motor requires can be obtained from power required for the agitations. Okay, and let X be the power required for the agitations. So then the power output of the electric motor, it will be uh, X is equal to the X plus power loss in a sealing system plus power loss in transmission system. So 1.1 and 1.2, those are the constants, and this one is a constants value, so we have to remember this. If you express output of electric motor in horsepower, then continuous average rated torque on the agitator shaft, that is tau c, is equal to the hp of electric motor into 60 into 75 divided by 2 pi n kgf into meter, where n is the rpm. Okay, so these equations give us the average value of torque. Using this equation, the average value of torque, starting torque is always greater than average normal torque. Starting torque can be taken equal to the 1.5 times to average torque at a lower speed of agitator, and can be taken 2.5 times average torque of for a higher speed. Starting ટોર્ક જે છે એ કેટલો કન્સિડર કરવામાં આવે છે, એવરેજ ટોર્કના 1.5 at a low speed, and at a high speed it will be considered 2.5 times. Okay, so the maximum shear stress can be developed in the shaft is given by equation f of s is equal to tau m upon zp, where tau m is the maximum torque developed in the shaft. Zp is the polar modulus of selections of shaft cross sections is equal to the pi d cube by 16. Okay, and fs is equal to 1.5 or 2.5 times of tc divided by zp, where d is the diameter of shaft. Okay, so other theorem or other modulus of cross section, that will be bending moment, and then these other types of stress, shear stress, will be created in the vessel. So this will be discussing in the next lecture.